Hello, in today's video I'll be going over radical substitution. So what is a radical substitution? Well, it's when a radical reacts with some other molecule and a substituent on that molecule gets substituted for that radical. So let's begin with what a radical is. A radical is a molecule with a lone electron, and they can be formed when UV light interacts with that molecule, for example here with a chlorine molecule, resulting into chlorine radicals. These radicals could then further react with, let's say, some sort of alkane like methane, which then would give you a methyl radical as well as hydrogen chloride. Then this radical here can further react with a chlorine molecule, forming this compound right here, chloromethane, as well as another chlorine radical. And what's so special about radical reactions and radical substitutions is that they are a sort of chain reaction, since this chlorine radical, which is formed right here at the end, can go back all the way to the beginning and start the process over as this radical right here, going into the reaction, reacting with the methane, forming this methyl radical, which then would start the process over again from the beginning. And so what type of reactions could stop the radical reaction then? Well, here we're going to write all those reactions. In this case, obviously it depends on what sort of radicals you have, but generally it's when the radicals themselves react with each other to form a stable molecule. So here, two chlorine radicals could react, forming chlorine gas, or a chlorine molecule, that is. You could also have a chlorine molecule reacting with a methyl radical right here, forming chloromethane. Or you could have two methyl radicals reacting with each other as well. Which would give you ethane. So yeah, and something interesting about radical reactions is that they're actually the type of reactions which have destroyed our ozone layer to a certain extent, since CFC substances, which stands for chlorofluorocarbons, have been released, and the UV light can split these molecules, forming halogen radicals, which then could react with the ozone, destroying the layer. So yeah, that's about it about radical substitution and radical reactions.